Hi students, this is Ms. Medina, and in this video we're going to talk about solving for consecutive integers. So in class today we talked about consecutive integers. Examples would be 3, 4, 5, 6, because all you're doing is adding 1 to each number. Here's another example of consecutive integers: 21, 22, 23, 24. So when that's the case, when you have consecutive integers, the first number is always going to be x. The second number is going to be x plus 1. The third number is going to be x plus 2, and so on and so forth. Every single time we add 1. The pattern for consecutive even numbers or consecutive odd numbers, they change by 2. Every single time we're adding 2 to the previous number. So 2 plus 2 is 4. 4 plus 2 is 6. It's the same pattern with the odd numbers. 5 plus 2 is 7. 7 plus 2 is 9. So when we're dealing with consecutive even or odd, the first number will be x, the next one x plus 2, the next one x plus 4, the next one x plus 6. All right, so let's go through the examples so that we can get really good at solving these problems, right? Oh, I'm trying to zoom in. There it is. All right, so number 1 says that we want to find 2 consecutive even integers whose sum is 126. So right here, they tell you that they want 2 consecutive integers. Ooh, even integers, which is why I'm highlighting this in green, okay? I lost my pen. There it is. All right, so we know we're going to have a first number and a second number. For consecutive even, the first number is x, the second number is x plus 2. And we want the sum of these numbers to be 126. So we need to add them, right? So x plus 2 equals 126. All right, so once you reach this point, it's just a matter of collecting your like terms and solving for x. All right, so I see that I have 2 x's. So that's 2x plus 2 equals 126. I want to solve for x, so that means I have to subtract 2 on both sides of the equal sign. All right, so I have 2x equals 124. All right, and the final step to isolate the x is I need to divide both the left and the right by 2. And I get that x equals 62. All right, so that means that the first number is 62, and the second number, which is x plus 2, is going to be 64. All righty, so these are the 2 consecutive numbers that add up to 126. Check. All right, next example. We want the sum of 3 consecutive integers to be negative 114. So in this one, it's just 3 consecutive integers. And I'm highlighting this in yellow so we can follow the color scheme that we came up with at the beginning. All right, so we need 3 consecutive integers. That means the first one is going to be x. The second one is going to be x plus 1. And the third one is going to be x plus 2. And we want the sum to equal negative 114. So that means we need to add these numbers. So we need this one plus this one and then plus that one. All right, so you have x plus x plus 1 plus x plus 2 equals negative 114. Okay, so now that you have this, it's just a matter of solving now. We have 3 x's. So that's what we're going to get 3x from. Hold on one second. It's going to give us 3x. And now the constants. right? This one right here and that one. 1 plus 2 is 3. All right, so now we want to solve for the variable. That means we have to subtract 3 on both sides. Sorry, I had a little bit of hiccups just now. All right, so we have 3x equals negative 567, negative 117. And the final step to isolate x is to undo that multiplication by 3. So we need to divide by 3. X equals negative, let me just do it in the calculator to make sure I don't make a mistake. 39, so negative 39. All right, so the first number is negative 39, right? The second number is going to be x plus 1, right? So you have to do negative 39 plus 1. It's going to give you negative 38. And then the third number is going to be x plus 2. All right, so for that one, it's negative 39 plus 2. And that's how you're going to get negative 37. Okay, so these are the 3 consecutive integers whose sum equals negative 114. And you can check that just by adding those numbers. All right, next example. The sum of 3 consecutive integers is 53 more than the least of the integers. So consecutive integers, 3 consecutive integers. So let's get them here. First, second, third. All right, so the first one is x, x plus 1, and x plus 2. So out of these 3 numbers, which one is the least of the integers? The least or the smallest is going to be the first one, x. 53 more than means that we have to do x plus 53. All right, but first we need the sum. The sum of the 3 consecutive integers, right? There's 3 x's. All right, so we have x, x plus 1, x plus 2. And we want this sum to be equal to 53 more than x. And so now we're just ready to solve. We've done this before. So this is going to give us 3x plus 3 equals x plus 53. Now you'll notice that this is the left side, okay? Right here. But we have an x term that's on the right side. And we want all of the terms with variables. We want all of the variables on the left. So we need to move this one to the left. So we have 2x plus 3 equals 53. All right, so on the left now, we have all the variables, but we want to move all of the constants to the other side. Okay. So now we really do have 2x equals, since it's not going to fit, I'm just going to continue over here. 2x equals 50, right? Because 53 minus 3 is 50. All right, and then now we just want the x. So we're going to divide both sides by 2. And we get that x equals 25. Okay, so that's the first number. we have to find the second number and the third number. So x plus 1 is going to be 26, and x plus 2 is going to be 27. And these are the three consecutive integers whose sum is 53 more than the smallest number. Whew. Right, next example, number 4. The sum of three consecutive integers is 71 less than the least of them. All right, so let's focus. We have three consecutive integers. All right, so all right, we know that they're consecutive, so that means this is x plus 1, x plus 2. The sum, so we're going to go ahead and add them. The sum of these is going to be 71 less than the least of the integers. So out of these three, which one is the smallest? The smallest is this one, x. So what is 71 less than x? Right, remember when it's less than, we have to swap them. We're going to write the x first and then the minus 71. All right, so I'm going to combine like terms on the left-hand side. It's going to be 3x plus 3. All right, again, this is my left side. I want all of the terms with x on the left. But there's this term right here, x, that is on the wrong side. It needs to be on the left side. So we're going to move it to the left side. Okay, so now we have 2x plus 3 equals negative 71. All right, we're narrowing down to the term with just one variable. So now we have to get rid of this plus 3. So we're going to subtract 3 on both sides. Right, we have 2x equals negative 74. All right, and then the final step to isolate the variable is going to be divided by 2. All right, so we get that x equals negative 35, 36. I get negative 37. Let me just double check in the calculator. Yes. So that's the first number. And remember, we have to calculate the second number and the third number. So we have to find x plus 1, x plus 2. Right? So you're doing negative 37 plus 1, and you're doing negative 37 plus 2 in your calculator. And that's how you're going to get negative 36 and negative 35. Number 5, another example. Find two consecutive odd integers. So this has two consecutive odd integers. Right? So first and second, because we only have two integers. So we're using the color scheme. These are odd. That means that the first one is x, and this one's going to be x plus 2. And we want the sum to be 111. So that means x plus 2 equals 111. I'm just going to use my highlighters. All right, I have two terms with x. X plus x is 2x. So this is 2x plus 2 equals 111. Now we're focusing on just the term with the x. So that means we have to move this to the other side. That's why we're subtracting 2 on both sides. All right, so now we have 2x equals 109. That makes sense? And so now we're going to divide by 2. And we're going to get that x equals, having apprehensions, 54.5. But this is not an integer. Right? Because integers are going to be -3, -2, 1, 0, 1, 2, 3. Okay, so because we got a decimal, this means that these two consecutive odd integers don't exist. Okay, so do not exist. All right, they have to be integers, basically the whole numbers, whether they're positives or negatives or a 0, okay? So, I mean, we can try. We can do 55 and 57, right? But then you're going to get 112, which is not 111. So no, it's not going to work, okay? All right, so those two odd integers do not exist. All right, number 5. The sum of 3 consecutive even integers is 138. All right, 3 consecutive even integers. All right, and we have 3 of them. So it's the first number, the second number, the third number. And for even, it's going to be x plus 2, x plus 4. And we want the sum to be 138. All right, so x plus 2 plus x plus 4 equals 138. All right, so let's collect our like terms. I see 1, 2, 3 of them. And then now look at the constants. I have a plus 2 and a plus 4. So that means plus 6 equals 138. All right. Oops, sorry, hold on. There we go. All right, so now focusing on this one, we have to do -6. All right, so now we have 3x equals 132. All right, we're focusing on that x. Now we're going to divide by 3. So x equals 32 divided by 3, 44. All right, so the first number is 44. Now we need to find the second number and the third number. So for that, we need to do x plus 2 and x plus 4. All right, so in your calculators, you're going to do 44 plus 2. Do 44 plus 4. So that's how you're going to get 46 and 48. So now these numbers exist, and you can check in your calculator that if you add all of these, you get 138. Okay?